So I titled these notes K-values or quantiles and inverse normal. So we kind of already did both of these yesterday, right? K-values, quantiles. K-values are the unknown values that are along the x-axis of the normal distribution. And we use the inverse normal command to take a probability and return the unknown x value, or z value if you're talking about the standard normal. And I've talked a lot about the fact that sometimes using the standard normal is better for us than using whatever normal distribution we're working with. Well, sometimes you don't have an option. Sometimes your hand is forced, and you're going to have to use the standard normal. Like I said, a lot of the countries, I'm assuming a lot of the countries, I think they all default to standard normal, because in the mark schemes, I see questions that you didn't have to use standard normal, and yet they did. So I think that that's a known thing around the rest of the world. I think a lot of other countries are taught, yo, just immediately convert to standard normal. I don't know why, but yes?
I thought the inverse normal was yesterday when we did like if it was 0.8, it would be 0.2 when we find out. Is that not what that is?
Inverse normal, okay, so let's do it like this. If you have an x value with a mean and a standard deviation, then normal CDF gives you the probability, which is the area. Inverse normal, if you give the probability, aka the area, with the mean and standard deviation, it returns the x value that gave you that. So it just
So inverse normal finds k.
Inverse normal finds k, which would have been an x value.
Standard normal finds area.
No, standard normal just means you're talking about z-scores, mean of 0, standard deviation of 1. So the inverse normal is used for both the standard normal and things that are not the standard normal, just anything that's a normal distribution. You can use inverse normal no matter what, yeah. Inverse normal will give you inverse normal takes an area either from the standard normal or just any other normal and gives you back the k value that is associated with that area.
So in theory, we don't have to, like, we could use the inverse normal on, like, homework number, like, 3?
I don't know, because, yeah.
So when are you talking about that our hand would be forced to use standard?
So sometimes we're forced to use the standard normal distribution. And this example right here is one of those times where we're not going to really have much of a choice. And you'll see why in just a second. Okay. Alrighty, so get this chair out of my way. So when do we not have a choice? It says, well, we always need to convert to z-scores if we're trying to find an unknown mean or an unknown standard deviation. You see, you can't do the normal CDF if you don't know both the mean and the standard deviation. When you go to use normal CDF, it defaults to mean of 0 and standard deviation of 1. Now, when we were using the normal CDF, we were changing the mean to whatever we wanted it to be and the standard deviation to whatever we wanted it to be, but that's only because we could. That's only because we knew those values. So what would we do if we didn't know them? If we didn't know one of them, or worse, either of them, you would be forced to use the z-score, which is going to be the standard normal. An adult scallop population is known to be normally distributed with a standard deviation of 5.9. Notice, I didn't give you the mean. I've just told you the standard deviation. 15% of the scallops, also known as the area, probability 0.15, 15% of the scallops weigh less than 58.2 grams. Find the mean weight of the population. So anytime you have an unknown mean or an unknown standard deviation, standard normal is going to be what you have to use. Where is my stylus? Well, you can use inverse normal with the standard normal distribution because the standard normal automatically has mean 0, standard deviation 1. So you always know the mean and standard deviation for the standard normal. So let me illustrate what we're talking about here. We have some normally distributed population of scallops. We don't know the mean. It's an unknown value. It's an unknown k value. What we do know is the standard deviation is 5.9, and we know 15% weighs less than 58.2. Okay, well, 15% is a lot smaller than 50%. So we know that this value of 58.2 is to the left of my unknown mean. So I'll just put it right here, 58.2. And the space that this covers is 0.15. Cool. So I don't know the mean. I do know standard deviation, though. Sigma equals 5.9. Okay. So let's say we know that the mean should be mu, or I have it written as k, whatever, doesn't really matter. I only called it k because it's an unknown, so it's a k value. But that is mu. That is your mean. So let's say let x, capital X, be the weights of these things. What we know is that capital X, because we've been told, is distributed normally. But it has an unknown mean, standard deviation of 5.9. So we're just trying to get marks at this point, right? I don't know my mean. But I do know the mean and standard deviation if I convert them to z-scores. So if we can convert to z-scores, then we're going to be in much better shape here. Because z is distributed normally with mean 0, and goodness, I can't write too fast because the computer can't handle it. 0, standard deviation of 1. What we know is that the probability that x is less than or equal to, or just less than, because it doesn't matter when you're talking normal, 58.2 is 0.15. Cool, this is what we know so far. Let me remind you how you find a z-score. A z-score is calculated by doing x minus mean over sigma. Good? So then what I'm going to do is I'm going to find the z-score that is associated with the area of 0.15. You know what? I forgot to write z. I'm sorry. Come on. There we go. 58.2 minus unknown mean. Sigma was, what was it? 5.9? Yeah, 5.9. So what I'm trying to do is find the z-score that is associated with the area of 0.15. So finding a value that's on the horizontal axis is done using inverse normal. Normal CDF takes the area, normal CDF gives you the area. Inverse normal takes the area but gives you back the x or k or z value that created it. So we use inverse normal with the standard normal because the mean is 0 and the standard deviation is 1. So I'm going to go to my graphing calculator. Somewhere, it's here somewhere, there it is. Second vars, inverse normal is 3. The area is 0.15, and I am going to the left because that's where I shaded. Okay, stop. It says 15% is less than, correct? So that's a left. And we're using the z-score at this point. That's why I did z. It,
Why is it not
5.9.
because I'm using the standard normal, where the mean is automatically 0 and the standard deviation is automatically 1. You can't use inverse normal on a regular normal distribution unless you know both the mean and the standard deviation.
So you can just switch it?
That's the whole point. It's a conversion that always has the mean of 0 and standard deviation of 1. When you don't know the mean or the standard deviation of your normal distribution, you will be forced to use the standard normal.
And it gives you the same answer.
It's going to give you a z-score on the z curve. I'll draw it, okay? Just give me a second. The answer is negative, let's see, 3 sig figs would be negative 1.04 actually. I went much farther just because I wanted a lot of decimals. I did negative 1.0364. That's what I'm going to say that is. Negative 1.0364. Before I go any further, let me draw what I just did. This is the z distribution. On the z distribution, your mean is 0. Your standard deviation is 1. We just found that the z-score of negative 1.03-ish, 364, has 15% of the data to the left of it. So we just found a z-score associated with the area of 15% to the left.
what is the z-score?
Because this is the equation for z-score, and I know the z-score's value, I can isolate mean now. So you multiply both sides by 5.9.
Is this the mean of
The mean of the original distribution, because we didn't know it. Right. Now the mean of the z distribution is 0. And that gives, so when you multiply both sides by 5.9, you get about negative 6.1. And then you just add mu and add 6.1. And what you get is that mu is about 64.3. Yeah. There, which is what we were trying to do. This was the easy one. Yes.
I don't understand the steps where you like probably a z is less than equal to
Okay, so here's what we did. I was trying to figure out what z-score was associated with 15%. But since I didn't know what that value was, I just used the formula for how I was going to find that z-score. Because this is the formula for z-score. I needed to know what value of z has 15% to the left of it. That's what I needed to know. And once I found that value of z, which was negative 1.0364, I was able to set it equal to the equation for finding a z-score. So this was just saying z is less than some number that I don't know yet, but I do know that the value, the area, will be 15%. That's what that was saying. And I then took the unknown and I go, oh, well, now I know the unknown value is negative 1.0364, which gives me the ability to solve for mu. Now, if you were to go to your, just to prove a point, let's go to our calculator. This question's finished, by the way, but let's do VARS, normal CDF. The lower bound, essentially 0. The upper bound, we would need to do, no, the upper bound is, oh, we never even found out what value that is, did we? Oh yeah, 58.2. I'm sorry, yeah, 58.2, thank you. The mean that we just found is 64.3. And our standard deviation was given to us 5.9. And just listen, what I'm doing is I'm demonstrating that this should give me back an area of basically 15%. This should show me that there is roughly 0.15 to the left of the number 58.2. I'm just verifying that it works. This should be darn near 0.15. See, it's pretty close. Again, we had to use z-scores because you always know mean and standard deviation for z-scores. If you don't know the mean or you don't know the standard deviation, you are forced to use z-scores. What's up? Traven wasn't here, right? Right, that's because you have an older calculator like me. Yours automatically goes to the left, which is fine, just like my calculator. My one on the computer goes left, right, and center, which, to be honest with you, does make life really easy. But I'm going to teach as if you can only go left because I know some of us have a calculator, including myself, that can only go left. Okay? Yes, Gavin?
My calculator will let me do the normal. It will only do the inverse normal, and it just puts the normal CDF in the area of the inverse normal.
You need to hit clear a bunch of times. Second quit and clear. Now just try again. Okay? All right. So I was just demonstrating to you that it worked. That's all I was doing.
Okay.
I was verifying that the answer is working. Okay? Okay. Just going to clear this now. And let's go back to the notes. So like I said, that was the easier one. Why was it easier? Because there was a single unknown.
And when it's both unknown, you just assume a zero.
Well, when there's two unknowns, what do you generally have to have in order to solve for two unknowns? A system of equations. So what we're going to have here, because I have two unknowns, is a system of z-score equations. So if you have a calculator that can go center, life is good for you. I'm going to go left only because that's all my calculator can do that I have to hold in my hand. Now the one on the computer, it's easier. Find the mean and standard deviation. Again, the moment you don't know one of those, you instantly know you're working z-scores. That's the dead giveaway. Oh, I don't know mean and standard deviation? Z-scores. Dead giveaway, okay? Find the mean and standard deviation of a normally distributed random variable x. If the probability that x is less than or equal to 20 is 0.1, then the probability that x is greater than or equal to 29 is 0.15. Again, pictures help us deal with what we're looking at. So we have our randomly distributed variable, normally distributed variable, excuse me, unknown mean, unknown sigma, very bad sigma. But what I do know is that there is 0.1 to the left of the number 20 and 0.15 to the right of 29. Picture on scale. So here I have an area of 0.1 and here I have an area of 0.15. How did I know that 20 was to the left of mean? Because there's 0.5 to the left of mean. So if it says there's only 0.1 to the left of a number, well, that number is pretty far to the left of mean. And the same thing's going to happen on the other side. I know there's 0.5 to the right of mean. So if I say there's 0.15 to the right of 29, then I know 29 is to the right of the mean. Here we go. That's all I'm given. That's it. You go, okay. Well, here's what we know. We know that since the probability, I have to write so slow, that x is less than or equal to 20. No, I'm going to use z. Is equal to 0.1. I could convert this to a z-score. So say that the probability that z is less than or equal to 20 minus an unknown mean divided by an unknown sigma had better also be 0.1. You see, I can use inverse normal to find the z-score associated with the area of 0.1. Does that make sense? Okay. This is on my x distribution. I'll draw the z distribution. Z-scores are found by doing x minus mean over sigma, correct? So this z-score right here is x minus mean divided by sigma. This z-score over here, so if you want to call it like z1 and z2, is, what's the other one, 29? X minus mean divided by sigma. It's supposed to be 29, there we go. So we're going to find the two z-scores associated with those areas, okay? That means the other z-score is the probability that z is, you know what, I don't want to say greater than or equal to because my calculator can't go right. My calculator can only go left. So z2, if z2 is 0.15 to the right of it, what's to the left? 0.85, you know, 1 minus 0.15. Okay. That is Z1 and Z2. So I tell you what, Z1, Z2. That way they match the picture over there. Because my calculator can only go left, I had to say if 0.15 is to my right, then I guess 0.85 is to my left. Okay? And then after we do this question, I'm going to show you how the other calculator makes this question a joke. It's like unfair. It really is unfair. All right. It takes like a 7-mark question and turns it into a 3-mark question. It really does.
I need the simplicity.
It really does, which tells me that IB is probably going to change these kinds of questions just to circumvent the technology, because the technology does the questions for you. It's kind of like how, you know, how creatures would try to, it's like, you know how the koalas, they eat eucalyptus leaves? So the eucalyptus plant developed a toxin so that it's poisonous for animals to eat. So then the koala bears develop basically an antitoxin in their body so they can continue to eat the eucalyptus leaves. It's an arms race. So at this point, TI is trying to keep up with, you know, IB and TI are trying to outwit each other. Okay. Drunk?
Yes.
Huh. Interesting.
You know that, Harrison.
I just know random facts about it.
Second, bars. Inverse normal. The area that we're talking about here is 0.1 on our standard normal curve, going to the left. So this is going to give me Z1. As it turns out, Z1 is approximately negative 1.282. Did I take 3 decimals? I did. Negative 1.282. Z1 is negative 1.282. Let me go find Z2 now. Inverse normal. Now my area is 0.85, still going to the left. .0364. Wow, really? 1.0364 again? That's crazy. Oh, no, it's not, because they both had 15 to the right. That's why. Okay. Negative 1.0364. I did 036. I just took it to 3 decimals. Positive 1.036. There. Just so you know, I'm only filling out this image over here to make it easier for you to understand what we're doing. These pictures are not on the notes I have in my hand.
Would they give us marks in the test?
What's that?
Would they give us marks in the test?
I don't know. Sometimes, yeah, it'd be worth method marks and things like that, or recognition marks, like student recognized they had to use standard normal, things like that. Cool. So here's what I know. I know that Z1, which is negative 1.282, can be found by doing 20 minus mu over sigma. So if I were to get rid of the fraction, I can multiply both sides by sigma. There. There's one equation in terms of sigmas and mu's. And the other one,
So you multiplied each side by
sigma, just to get rid of the fraction. Because here I have a system of equations, and systems of equations stink when there's fractions involved. So multiply by both sides by sigma again. There. I now have two equations. And the way they're written, they're linear equations. So I'm simply going to stack them, and I'm going to use elimination. I do not want to use substitution. I could. I don't want to. All right? I'm just going to do this. This computer lag is really hurting me right now. No, there's nothing they could do about it. It's just because it's because I'm trying to stream and record at the same time, so it's really pushing this thing to its limits. It's not up to me, is it? It's school-provided technology. There. What I'm going to do is I'm going to subtract straight down, good old Algebra 1. And the reason why I'm going to do that is because it's going to cancel out the mu's. So subtracting straight down. Subtracting straight down is going to give me negative 2.318 sigma equals negative 9. So you just divide both sides by negative 2.318, and you find out that sigma is 3.88. And just like any other system of equations, once you know one of the answers, you just plug it back in to get the other answer. So you just pick one of the two green Z1 or Z2 equations that I wrote. I'll go with Z1, I think. Is it easier? I don't know. Well, anyway, so we go negative 1.282. Okay, for some reason I was saying 2, but writing a 9. Negative 1.282 times the sigma you just found of 3.88 equals 20 minus mu. Little bit of math trickery. Add m or mu to both sides and add this multiplication to both sides. You get that mu is 1.282 times 3.88 plus 20. What you find is that your mu is approximately 25. This question's finished. Wow. Wow, wow, wow. Now, wait a second. Now, it makes the question a lot easier, I believe, having the calculator that can go center. If there's not a lot, but if there's 0.1 to the left and there's 0.15 to the right, you realize the center is 0.75, right?
Yeah.
Okay, watch this happen. No. Second vars, inverse normal. The area is 0.75. in between two things.
No way.
So what it does is it will not go to the next line for some reason. It gives you both of your z-scores.
Bruh.
It just hands them to you.
Bruh.
You can get a software update, yes, you can. You have to go to the TI website, and there's a way to do it on there. You just have to be able to hook it up to the computer, and it will update the operating system on the calculator. So really, though, all it did was it just gave you the two. It gave you the two z-scores. So you still had to realize. You still had to realize you needed to use z-scores, and you still had to realize you needed inverse normal. It just gave you the two z-scores. You still have to do the system of
How
equations.
would you know? Wait. Pause. Those z-scores are wrong, aren't they?
That's assuming they're equal.
Yeah, because you put in 0.75, not 0.85.
No, it's assuming it's equal.
Aren't those z-scores are the same?
Hold on. No, you're right. Those aren't the same, but I'm trying to figure out.
That's saying if like each side had the same amount on each side. Those
Right, right. But then you realize that they were off by like 0.5 on each side or something like that. That won't work that way. I'm trying to remember how to do it then, because there is a way to do it, and it'll hand you the two. How do I do this? There's a way to do it. There's definitely a way to do it. I used to do it. Here's the thing, because I don't have a calculator that does this, I don't know how to make it work right. Hold on a second. Now I can't remember how to do it. I'll keep thinking about it. But the question's finished anyway. You don't need to know how to use the center and the right, because everybody's calculator can go left. That's all I need to know. So that's where I'll stop the video, because I don't want to have dead air while I'm trying to figure out how to make it work.